now and say thank you for joining us. And I hope you can all see the presentation there. And I'm just going to give you a little bit of an introduction to heat pumps, and particularly Daikin first, for those of you who don't know us. You'll probably see the slide there at the moment. It's probably something you're used to hearing in a lot of older houses and people going in there, and you can see what it kind of means, and the little sticker on the controller there. But basically what we're trying to do in Daikin is make houses an awful lot more comfortable, warmer, and that's the aim of what we are doing here. So a little bit about what we're going to chat about this morning, and myself, my colleague Manus, and we'll cover some of the very little bit about Daikin first, but the basics then of heat pumps, heat load calculations, heat meter selection, designer installer sign off, eco design data then, and deep, and then we'll have a Q&A at the end. So if any of you any questions or anything as I go along, put it into the chat box there, and the lads will look after it for you then. A little bit about Daikin for those of you who don't know. Starting off, we are a fairly old and well-established company, starting in 1924. Founded in Osaka, Japan, and our worldwide headquarters is Osaka. Our European headquarters is in Belgium. We can do anywhere from -45 to that symbol. The big symbol you see is the infinity symbol. So district heating systems, which we've done a lot around the Middle East, Malaysia and that, and they're starting to come into their own here. One in Dublin, we're working on a second one down by the docks at the moment. Anything from zero carbon emissions from 2050, that's in all our production and our transport, every part of it, down to, as you can see there, we have a fairly big payroll every month, over 96,000 employees at present, and in 173 countries around the world. We've over 90 production bases, but most of all our heat pumps for Europe are manufactured in 14 plants in Europe. Particularly, we do a lot of heat pumps out of our Czech Republic, and particularly Belgium as well, where our European headquarters is. And they're all manufactured in Europe for Eurobrand certification. So that's all the data and the certificates independently certified for ourselves, for SEAI purposes and that as well. Something that's a little bit unique about Daikin in the world of manufacturing of heat pumps is we're the only manufacturer that makes both the refrigerant and the compressor. So we're unique in that field. The compressor is really like the engine of a really good car. It's the heart of the whole system. So it's very good to have a really good compressor. We don't buy in third party. We've been manufacturing our own compressors for many, many years now. They're very reliable and very, very efficient. For those of you who don't know, you probably have seen a lot of heat pumps with R32. That's the refrigerant in it. Well, Daikin invented that. We own the patent on it. And 2012, we introduced the first heat pumps around the world with R32. And in Ireland, 2017 was when the first went in with a retrofit project in Wexford. So it's R32 is what's used now by most manufacturers. We put the patent out there about 8 or 9 years ago for any other manufacturers to use it, because the GWP is a lot lower, and it was a lot lower than what was 410A, the old refrigerants. So as I say, that's part of our legacy into the world of heat pumps and that, etc. We're here in Ireland. We're set up in Dublin since 2007. We opened an office in Cork there early last year. So we have training facilities in both, and we don't install or anything like that. We're here to train commuters and then installers, I should say, and get them up to a very high quality workmanship, make sure that it's done right, make it easy for homeowners. And we're here to support the whole market. We've over 40 staff between the two offices. We've in-house engineering team, so if anybody's any queries on, be it from your end of it, be yours, or maybe just general consultants, architects, any questions, we'll give you an email address at the end there for any questions you want to send in to us on our in the offices here. We're here to support the dealers, installers. We have a lot of YouTube videos out there as well to try and help people under Daikin Ireland. If you wanted to go to YouTube, you can have a look at that and see that. I just want to give you very briefly the difference when you guys go to do houses, which you're doing your initial surveys. Maybe there's gas or oil boilers. What you're looking at changing it over to is either your choice. Geothermal we don't use so much now, really because the capital cost of installing it. We manufacture, as a manufacturer, still quite a few geothermal systems which you sell into the Nordic countries, because when there's 15 foot of snow up in Sweden or Norway or Finland or somewhere, the COPs can be better to get it out of the ground than to have an air-to-air system at -20. So we're lucky in Ireland. We have a very moderate climate here. We don't get extremes. So we don't get -40 like they do in the south of Spain in the summer, or we don't get minus 20s that they do in Europe. So we're very lucky here. A heat pump, an air-to-water heat pump is excellent here. So refrigerant split is one, or monoblocks are what you might hear coming across, and they're nearly as efficient now as ground source. And with the ground source, you have the capital cost of either trying to get a borehole in somewhere to start putting down boreholes. Very hard to do in a new site, or dig up half an acre of land out the back there. And it's okay if Uncle Jimmy has a bulldozer or something, or a digger, and he'll give you a land of it to do that. But most of us aren't in that position. So for the 1 or 2 or 3%, you'll get over a geothermal, and the other backup really is geothermal. There's not a lot of guys servicing them now because that generation there's some of them still out there, but it's not as easy to get serviced as you would for a standard air to water system. Refrigerant split really means it's split in two, is the easy way of explaining. You will have an indoor unit and an outdoor unit, and the connection is made with refrigerant gas, generally R32. And the big advantages of that is the fact that it won't freeze. So a lot of county councils, housing bodies like the fact of refrigerant in it rather than water from outside to inside, because the fact that if they've tenants, for instance, in a property and they leave in November, tenant leaves and then suddenly there's no power in the house because they were using pay-as-you-go meters or whatever. And then a really cold spell comes in before the new tenants come in March or something like that, the heat exchanger could freeze. So it's something that has to be very much taken into account. There are protections like antifreeze valves and all that can be used, but it's something that a lot of councils like that because the fact the system will never freeze because of refrigerant in it. So the house area, as I say, is there. You've got to determine the housing, the actual installation levels, you guys, which that's what you do when you go out to see how we're going to size the heat pump. Outdoor and indoor connected by F-gas, as I said. The big advantage there as well that you can have up to 30 meters between the outdoor and the indoor unit. So it gives you a bit more scope to move the actual outdoor down the garden. And because it's refrigerant that's in the pipes, there's very, very little heat loss from it. Integrated unit there, which you'll see, the big picture, it looks like a floor standard fridge. That means that the hot water cylinder is contained within that. Under the designer sign-off tool, it reaches very, very high efficiency because everything's well insulated. It's pre-plumbed as well, so it's a quick install. So you have a lot of flexibility to use. Daikin now are using mainly all single fan units, even in our bigger capacities, so 11, 14, 16 kilowatt, you'll see it's a single fan. We're the first in the world to be able to do that, eliminate the twin fan. And it makes it easier for architects or anything like that if you've got your system underneath the window or anything like that. So that's refrigerant splits. Easy to remember is split in two, indoor unit, outdoor unit. With a monoblock, generally you'll find that's nearer to the property because the heat is produced outside. The heat exchanger is outside on a monoblock. So that's where the heat is produced and sent into the building. So it's generally sent in through copper or multi-layer pipe. It needs to have a 1-inch minimum diameter in the pipe. So you're coring slightly bigger holes in the walls. And you will generally find the monoblock is up against the house. However, there'll always be a 300 mil gap at the back because the air is coming in the back and out the front. The thing is, you have a little bit more flexibility on the cylinders, so you can have any size cylinder you want, from 100 litres up to 500, 1,000 litre if you want, depending on the size and capacity of the unit. One of the other big advantages is the fact that you don't need F-gas. So the connection, as I said, in the refrigerant split in our last slide, that connection must be done by an F-gas or refrigerant engineer because plumbers wouldn't have the bottles or gauges or anything to do that. But with water, this is a straightforward water connection and they can do that. You're restricted to about a 10 meter to 12 meter run. Because, as I say, you have heat losses immediately because the unit is producing hot water outside, sending it inside. So the pipework must be very well insulated at that. Plumber makes all the connections, antifreeze valves will be required. And it's a great retrofit, straightforward for an old oil boiler that's there as well, providing all the fabric upgrades done inside and radiators in particular are sized right. You might come across a couple of projects where it's an old country house. Maybe they can't get the fabric upgrades done or the budget isn't there. We also do a high temperature unit. So the high temperature really means you don't have to change radiators or anything like that. You're maybe not looking at a fabric upgrade, so you're not going to get any grants or anything like that. But it'll produce 70 degrees, the same as a boiler will. However, the efficiency is a bit lower. It's about 300% as against maybe 500% on your standard low temperature system. Again, the connections between outdoor and indoor, and this is called a hydro split really, because you have indoor units, but again, you'll have an outdoor, but it's connected with water connection. So again, you're looking at 10 to 12 meter distance between them. So that's just to give you something in terms of what's there in the solution. So you have low temperature with your monoblock and your refrigerant split, and then you've a high temperature solution after that as well. Controls are really, really important. Those stats you see there are Daikin Madokas, but you'll see an awful lot of heat misers, probably the most popular out there, but there's an awful lot of controls that are out there. Very important. I'm sure you guys go into houses now and you don't see any controls at all when you're doing your initial survey. It's just switch on, switch off, or go to the shops, turn off the system. The house gets freezing again at night when they turn it off. So with a heat pump, you leave it on all the time, and you let the actual stat do the work for you. So that's reading. If your comfort level is 21 degrees in the house, well, you leave it at 21, but if it gets too hot, turn it up, turn it down. Certain days when you start to get into summer, it's not going to come on anyway, because the stats are reading the house is already at 21. There's no need to bring on the space heating, but you'll always have the hot water in the back. It's always going to be on because that's a separate zone within its usage. That is a misconception that some of the heat pump is always on. It's only brought on when there's a need and a call for heat, and that's controlled by your thermostat. Not like a boiler, as I said. You don't want to be switching it on and off, letting the house get hot, cold, because that uses an awful lot more energy. Low slope approach is always the best. So just get the house up to temperature and keep it there. Many factors affect the consumption. You say it's the usage patterns, flow temperatures, installation levels, etc. So there's a lot of things you have to look into when you're looking at the house. In terms of controls, as I said, you've got the controls, and all our systems can be used on the phone if you Wi-Fi, you can get remote access, etc. So all very straightforward. Hot water production within the cylinder, we'd always recommend people, you don't need to keep a hot water cylinder at 60 degrees. You go into some houses, you turn on the hot water, the steam coming out of the taps. It's a tremendous waste of energy. With a heat pump, we'd always recommend keep the water under 50 degrees. 48 degrees is fine. You'll take the grease off dishes at 46, max your shower under 39. And then it's already pre-programmed for what we call Legionella protection or disinfection. So generally in Daikin, it's pre-programmed for a Friday night, go to 60 degrees for an hour. But you can change that if you want your schedule changes for Tuesday morning or whatever. That's no problem. So you have full disinfection is already managed into the system. Yeah, you can set schedules if you want to. So if you're a low hot water user, you might have a schedule come on in the morning and have your couple of showers, and then again it's there again in the evening. Or you can set another schedule for a shower in the evening. If you had a crash or something like that, you might want to put in 3 or 4 schedules during the day. You can also have reheat. So reheat means anytime the cylinder drops below 10 degrees, 6 degrees, whatever you set it at, it'll reheat automatically. And in a Daikin system, you can have both, so you never run out of hot water. You're always going to have it there. What makes your heat pump run efficiently? It's really important that you make it run efficiently. So don't block or restrict the outdoor units. In other words, don't put cabinets around it or block fences in front of it. Set it up for weather compensation. You can do that. You can have, with Daikin system, you can have a set temperature if you want, or you can put in weather compensation. Underfloor heating is a great way of doing it, but weather compensation means it's adjusting the flow rate through the actual radiators or through the underfloor. Set your hot water tank for around 48 degrees. And if you've underfloor or anything like that's great. You could actually set schedules for night rate electricity and then let the concrete release the heat during the day. So it's a great heat emitter, that is. Stats, living rooms 21. If you have bedrooms and you have a separate stat upstairs, 18 degrees, is very, very good to do that. But avoid turning it on and off for long periods. That's the main thing. And in a lot of social housing, that's what happened. And in fairness, it's just an education factor. It's a human nature thing. If you see a light on, you think it's costing me electricity. But with a heat pump, it's actually the opposite, because if you can keep the house at a steady temperature, and just keep it kind of flatlined, it's a great way of doing it, and it will save on your energy bills as well. Get the entire system serviced annually, really, really important. At the moment, I'm hearing prices anywhere from about 130 up to 180 to have a service done, depending on how far the service engineer has to come along. So, but it's really important that it's serviced annually as well. Just a little bit then on what we call an air-to-air system, and I'm coming up to the end of this now. You might come across some places where you've maybe replaced storage heaters or something like that. So we've introduced in a new system. We always have what we call our air-to-air systems, but it's called Multi-Plus, where we can do heating, cooling, and hot water all in the one. And it just means that it's, say, a two-bedroom apartment. You could have 3 indoor units. You have one maybe in the kitchen, living room, dining room area, maybe a 3 kilowatt, and maybe a 1.5 kilowatt in each bedroom. That's serviced by an outdoor unit, and we have a hot water cylinder as well, 90 or 120 litres. So it's ideal for apartments or anything, or small, two-bedroom bungalows, anything up to about 90 square meters. That's kind of what we're looking at range. So for a lot of county councils, a lot of housing bodies, they're already started using these. So it's called Daikin Multi Plus. Very simple to use. You're eliminating a wet system, so no radiators have to go in. So big savings there. And what a lot of the councils find, when you're very small and restricted little floor areas in apartments, you're saving a wall by not having radiators up against. So it means you can actually push the furniture up against that wall. So that's a kind of added bonus. And the fact that there's cooling built into it as well. So if climate keeps changing the way it is, the fact that in a couple of years they can switch on the air conditioning and have cooling as well. So hot water, cooling, heating, cooling, hot water, all in the one system. So it's a phenomenal system. So if you wanted to keep that in mind, if you're doing any where it's a small little apartments or somewhere where there's storage heaters, it could be a kind of a solution for that as well. So the advantage really, it's a very high quality product, the Daikin unit. Some people go, oh, sure, it's a lot more, it's not more expensive. We are a little bit, but you are paying for really high quality in it. It's a very easy way to heat a house. You never run out of fuel. You've one utility bill, so you're not getting any standing charges for another maybe fossil fuel that you're not using. And once it's set up initially, then there's no interaction with the heat pump. So, I mean, all the homeowner's ever going to do is literally switch up and down the stat. That's all they need to do. So it retains a very comfortable temperature, even temperature throughout the house. I'm sure most of you either have one or been in houses with them. It's a really, really comfortable house 24 hours a day. Pair it with a ventilation system then for best air quality. Never run out of hot water. Very easy, user-friendly control panel on the Daikin unit. Simple to use. And overall, it just makes things life a lot easier. One thing we do have, though, on the last slide that I'm going to talk about here is what we call Stand By Me. My colleague Manus will talk a little bit more about it, but we have, you can register for this when you go to your search engine, Google, type in Daikin Stand By Me, and there's a couple of different sides to it. One is very good for BERAAI assessors because we have what we call HSN, or Heating Solutions Navigator. If you look under professionals and installers, basically you can size all your radiators for the house, do heat load calculations, unit sizing, everything like that. It's a full database of all our heat pumps, and it will do everything for you, give you a printout at the end. But for end users is what we've really aimed at that as well, so that if we install or somebody installs a Daikin heat pump, they can scan the QR code that's on it. That will upload it to the Daikin portal, but also to the installer's portal. And he gets back an immediate 5-digit code, which he gives over to the handover as a handover pack part to the homeowner. And he will tell the homeowner, look, register that now for warranty. Type in those 5 digits when you go on Stand By Me. And you're actually going to see a printout then on the website. So in other words, the homeowner gets to see the unit that it was installed, who installed it, when it was installed, make, model, serial number. And then they get 3 email reminders when service is due as well. So they can build up a whole service history. And an awful lot of the county councils are using it as well, and housing agencies, because they keep a note of where all their actual their schemes are set up, and they can see what ones were serviced, what needs service, and the full history is there of them as well. So I'm just going to hand over to my colleague Manus now. Thank you. If you have any questions on what I spoke about, keep a note of it. Yeah, put it into the chat box there, and Stephen or one of the lads will look after it, Liam or somebody, John, and they'll keep a note at the end. So Manus here, I'll hand over, and he'll talk you through the rest of the presentation. Thank you very much.
Thanks, Ian. So next up is the Stand By Me part. So within Stand By Me, you have the Heating Solutions Navigator. As Ian mentioned, on the Heating Solutions Navigator, you can do up your heat loss calculations, radiator selection, heat pump selection, You can generate piping and wiring diagrams and so on. And that is within the professional portal. So once you log into the Heating Solutions Navigator page, and if you create a new lead, you have the options of selecting the function of your, so if it's for heating or hot water or cooling, and then the type of emitters, underflow heating or radiators, and then the property type, if it's a new build or retrofit, if you have gas or hybrid or solar thermal. So once you select one of the products, it will take you onto this page of here. So on the top, you have a couple of tabs to complete. So the first tab is the zoning definition. So if you have underflow heating downstairs and radiator upstairs, you'll have the option to select that out here. And then next is your controls. So based on what's applicable for you, you would pick the selected control. So in most cases, it might be an external room thermostat. So you would normally click on that. And next is your load calculations. So within the load calculations tab is basically where we do up our heat load calculations. And now if we take an example of here, a typical semi-detached house, living room, kitchen, and the hallway of here. So these are the main common design temperatures where it is set at, and the outdoor ambient at -3. So for your main zone, you can add in your rooms. So if you click on new room, you have the option to select the type of room, and automatically it gives you the design temperature for that particular room, and you can modify the name of the room. And then similarly for your additional zone for your radiator heating, you would add it up out there. And now if we open up one of the rooms, for example, the living room over here, we'll have to complete the tabs over here, which is basically all your fabrics, your floor, ceiling, and your walls. So for your floor, the type floor, if it's a ground floor, internal or a party floor, the surface area, the heat transfer to, and the U value. So if the U value is unknown, you can pick an option from the drop down of your, and that is going to be based on the building regulation, if it's a new build 2011 or 2019 and so on. Or if you know the actual U value of that particular fabric, you can directly enter that value of your. So this is where the BERAAI report comes in hand, and it helps us to accurately size your heat pump. And next is your ceiling. So again, the type of ceiling, if it's an external, internal, or party ceiling, your surface area, heat transfer to, and the U values. Now, if you take a look into the walls, so similarly, we have your, if it's an external type wall, internal or a party wall, and then your dimensions of that wall and the U value of that wall. And if it's an external wall, you have the option to select windows and doors and add the surface area and U value of that particular window. Similarly, for an internal wall, it will give you the option to select heat transfer to an internal room. So once you do up your heat loss calculations, you will normally see a green tick mark on the right over there. And that means that your heat loss calculations has been completed. And next is your radiator calculations. So that's an optional step. So if you want to do your radiator calculations within this tool, you will be able to do that. Now in this example, we've done up our heat loss calculations, and all of the rooms and heat loss has directly been transferred onto the radiator sizing tool. So basically now we'll have to select each room and pick a radiator from the list, or if you want to keep any of the existing radiators, or to check if the existing radiators are sufficient, you can do that over here as well. And currently we have a few makes and models at the moment, but this can be modified as well. So if we take a look at an example of here, so radiator 1, so the required heat loss is 499 watts, and this is a Stelrad compact. So you have the dimensions of the radiator over here, which you can modify, and the type of panel. So if it's a 2-panel, 2-convector, and then you keep increasing the width to get the required output. So over here, if you see a 5 by 1.1 gives 533 watts, which is sufficient for that room. And likewise, you would complete it for all of your other rooms in the property. And then once that's done, you go back to your main page, and the tool will recommend a heat pump for you. So in this case, it's recommending a 4 kilowatt unit, and out here you can see the capacity of the heat pump, your backup heater capacity, if there's any spare capacity, the consumption per year, energy costs, and efficiencies. So basically, we will click on the button select, and it will take you to this final page of here, where you can add in your customer details, and then you can generate your report. So once you generate your report, this is how it's going to look. So your main page of the report is going to have your project details, the location, and so on. And then towards the middle of the report, you would have your heat loss calculations that you've done. So this is the overview or the room by room heat loss calculations that you've done. Again, up here, you have your rooms, your surface area, design temperature, air change rates, and your heat load. Now, moving on to the sign-off forms or the design installer sign-off forms. The first tab of the sign-up form is basically all your default or your basic information on your property and your heat pump. And then towards the second tab is basically the heating design tab. And that looks like this page over here. And this is where we fill in all the details from the report. So in this case, so basically you fill in your room names, your room heat loss, type of emitter, the manufacturer name, the model or the size, the output of the radiators, and the heat and the number of emitters. And on top of here, you would see the flow temperature, the design flow temperature, and the return temperature. Normally, if it's for radiators, it would be designed at 45, 35 in this case. And then at the bottom, you have the option to enter the area of your dwelling and the heat pump output at design condition. So that's basically the output at -3 and 45 flow temperature. And then the third sheet on this sign-off form is the radiator output conversion tab. So this is where we basically copy the outputs from the radiators, the manufacturer's data sheet. So you would have the heat output from manufacturer over there. You'd copy it based on the size. You'd paste it in of here. And then the delta T of that, which is normally 50. And you have a conversion factor of here, and that's the formula. And then it automatically calculates the value for that. So basically, this tab of here should match the values of here should match the values in the previous tab of here. So we see 302453. So that adds up and matches to the ones over here. Now moving on to like eco design data. So on our website, if you log into Daikin.ie and if you navigate all to the bottom, you would see energy labels. If you click on that, it will take you to this page over here where you can download your data for your deep or PR assessments. Now, if we take a look into one of the heat pumps to add it into deep, so basically you create a new library item, you add it in as a heat source, an add to water heat pump, and you put in your model, make, and the heating and water standards. So this is always going to be EN14825, EN16147. And then these are your efficiencies from the eco design data. And then these are your temperature operating limits. And then the next tab, which is the heat pump test data. So this is where you copy all your values at low temperature and medium temperature for different conditions, -7, 2, 7, 12, and TOL. And then finally is your EN16147. So this is your hot water standards. So you have the option to either enter the COP or the efficiency. So if you enter the COP, you have that over here, and then your reference hot water temperature. So all of this is basically copied from this section of here. Hot water rated output, volume of THW accounted for a test. And then when you add the item, it will give you a pop-up of here, which basically asks you to enter the design flow temperature, the hours of operation, and the type of DHW. So if this heat pump is heating water for your hot water requirements, you can select that option. If it's providing cooling, you have that option as well. And in this case, you will need to enter the seasonal energy efficiency ratio for this to be highlighted or not grayed out. And then design flow temperature. Normally for heat pumps, this would be at 45 to 55 for radiators and 35 for underfloor heating. And in this case, if you change the design flow temperature from 55, which is the default, to 45, you will require you'll need to submit evidence for that. So you can submit the heating design sheet from the sign-off form as evidence for that.
Yes, yes.
And in this picture of here, normally if you see for heat pumps, the flow temperature would be designed for 45, and the radiator would normally be slightly bigger than a gas boiler running at 60, with radiators smaller in size.
No, like give him a ring and just tell him that you were talking to me and you want.
Then the last page is the options and storage. So under your water heating tab, so all of these can be selected.
All right, okay. Look, I'll ring him. I deal with him all the time.
Integral unit, you have the option to select integral hot water storage. If it's a monoblock or a hydro split or with a separate hot water cylinder, you have cylinder indirect option over here. And then similarly over here, you have the type of DHW. If it's an integrated flow standing unit, you have that option to select integral hot water storage. If it's a separate hot water cylinder, if it's connected to a monoblock, you have the option to select separate hot water cylinder. And similarly of your primary circuit loss types, so heat pump and thermal store within a single casing, in case if it's an integrated unit. And then next is your multiple heat pumps in dwelling. So if you have multiple heat pumps in a dwelling, you need to complete this Excel tool of you, which is the deep heat pump calculator tool. And you have 3 tabs in total. One is your basic input tab, and then your HP1, HP2, and a HP3 tab as well if you have 3 heat pumps. So it's basically you're entering all of your eco design data of your in your HP1, HP2. You need to enter the percentage of your heating system. So if it's 100% for domestic hot water for HP1, or 50-50 for HP1 and 2. So you have that option of you to select, and the tool automatically generates or calculates the heating efficiency in this case. And that's how it would normally look in Cascade. In this case, it's 6 heat pumps in Cascade. So that's it from our end. We hope you found it both informative and beneficial. Our contact details are as follows, and if you have any questions or future queries, you can email us as well.